Hi. Once again, welcome to Varenya's Photon Online Educational Academy. This is Guntuka Srinivas. It is a free educational channel meant for 8th standard to the 12th standard students. If you like the video, please share it, like it, and subscribe the channel. Encourage the channel. And in the previous class, we have seen about the distance and displacements and numericals related to the concept. Let us see some more numericals related to the above concepts. Let me take up the first problem. An athlete, that means sportsman, completes, an athlete completes one round of a circular track of radius 50 meters in 30 seconds. In the 30 seconds. What is the distance covered? What is the distance covered and displacement at the end of 2 minutes 15 seconds. 2 minutes 15 seconds. Clear? That was the question. Observe carefully the question. Athlete means a sportsman completing one round of circular track of radius how much? 50 meters. In how many seconds? 30 seconds. Now, what he's asking? He is interested in the distance covered, displacement at the end of 2 minutes 15 seconds. The clarity at the end of 2 minutes 15 seconds. Is clear? Now let us solve this problem. Observe here. This is a circular track. Let us say this is a circular track. This is a circular track. Now let us say that athlete is starting from A, point A is starting, and the track is having a radius of, this is center of this track, it is having this radius. Radius is how much? 50 meters. So radius of track, circular track, R is equal to 50 meters. Clear? Now, athlete starts from A and completes one round. Teaches here. In how many seconds? 30 seconds he gets in one round. That means total distance. What is distance? First he is interested in the distance. What is the total path length traveled in the one round? 2 pi r, circumference. Clear? Here I highlight it. The total path length traveled in one round. Means in one revolution, one circular, one rotation. How much? Circumference of the circle, 2 pi r. 2 pi r. 2 pi r is how much? 50 into 50 meters. So it becomes 2 into 50, 100. 100 pi, 100 pi meters. 100 pi meters. How? 100 pi, 100 pi meters. Here, in one round. In one round. Total path length traveled in the one. But he is not asking in the one round. Have the clarity. He is not asking in the one. He is asking in the at the end of the 2 minutes 15 seconds. Clear? And have the clarity. Have the clarity that these 100 pi one round distance is traveling in how many seconds? Time clearly given. One round is in 30 seconds. This entire distance is traveling in the 30 seconds. 2 pi r. Entire distance 2 pi r is traveling in the 30 seconds. Okay. Now, let us see that first one. What is asking? Distance traveled at the end of 2 minutes 15 seconds. 2 minutes 15 seconds. Clear? 2 minutes 15 seconds. 2 minutes. 1 minute is 60 seconds. Plus 15 seconds. 15 seconds. So entire time is how many? 120 seconds plus 15 seconds. So total 135 seconds. That means I am converting the time minutes into seconds. 2 into 1 minute is 60 seconds plus 15 seconds. 120 plus 15, total 135 seconds. So at the end of the 135 seconds, is asking. Clear? Now, observe. Clear? Athlete completes one round in how many seconds? 30 seconds. 30 seconds. One round in the 30 seconds. And in 135 seconds, how many rounds he will complete? How many rounds? Because we require at the end of the 135 seconds. In one round, 30 seconds he completes. Total at the end of 135 seconds we require. So in 135 seconds, how many rounds he completes? How many rounds? That is the question. So hence, in 135 seconds, 135 by 30. 135 by 30. Clear? 135 by 30. So if I simplify this, 3 4s 120. Okay. Clear? 0.5. So 4.5. 4.5 rounds. 3 4s 12. 0.35. So 4.5 rounds. How many rounds he completes? In 135 seconds, he completes 4.5 rounds. That means complete 4 rounds and half more. Yeah. Now, what is he asking? Distance traveled. Distance traveled at the end of 2 minutes 15 seconds. 2 minutes 15 seconds means at the end of 135 seconds. How much? In one round, how much is traveling? Already we have calculated in 30 seconds how many is traveling. In one round, how many is traveling? That is 100 into the pi. 100 into the pi. In one round, it is 100 into the pi. In 4.5 rounds, four and a half rounds, multiplied with distance traveled in one round, 105 meters. 105 meters. So 4.5 into 105, 455 meters is the total distance. Clear? In one round, it travels 105 meters. So in 4.5 rounds, in 135 seconds, it completes 4.5 rounds. In 4.5 rounds, how many rounds? How much distance? 4.5 rounds into distance traveled in the one round. Distance traveled in the one. 4.5 rounds multiplied with the distance traveled in the one. Clear? Yes. This distance travel in one round. Distance traveled in one. So 4.5 rounds in 135 seconds multiplied with distance traveled in one. So complete. This is the answer. 455 meters. M stands for meters. Clear? This is the answer for the first question, distance. Now, E needs the displacement also. Second one is displacement. Displacement. Okay. Observe. This is the round track. This is the round. This is the round track. Round track. Suppose person is here. Person is here at A. Now, how many rounds at the end of 4.5 rounds? We need the displacement. So first round, he starts from A, completes first round. Again, second round comes here. Again, third round comes here. Again, fourth round comes here. For the 4.5, this he goes up to the A dash. Only half round. First round, second round, third round, fourth round to the A1. Half round up to the A dash. So final point is this one is the final point. A dash is final. This is initial. Now, what is the displacement definition? Displacement definition is length of the straight line joining the initial to final point. So initial to the complete final point. So this is the diameter. This is nothing but diameter. A dash is displacement. A dash is displacement, which is nothing but diameter. What is diameter? 2 into R. This is the center of the track. 2 into R. So 2 into radius is given 50 meters. So 100 meters is the distance. 100 meters is the distance. Direction is from where to where? Initial to final point. Here I quote direction. Direction of vector is A to A dash. Initial point to final. A to A dash. Here. So complete at the end of the 135 seconds. He completes 4 rotations and half more rotation. So final point goes up. So initial to final is diameter. That is the distance. Clear? Now let us take up another problem. This is second problem. An object moves from point A to B, point A to B, comma, to C 2c, ein, to d, to d. Along the circle of radius, along the circle of radius 4 meters, along the circle of radius 4 meters, as shown in the figure, as shown in the figure. Figure is given. Clear? Find distance and displacement. Find A requires distance. B requires displacement. Read the problem carefully. Object is moving A to B, then to C, then to D. Okay? A to B, then to C, then to D. Clear? Along the circle of radius is 4 meters, as shown in the figure. We require the distance as well as displacement also. Distance and displacement. Okay. Now, observe. He has given a figure here. This was the figure provided to you. This was the figure provided. This was complete circle. This is a circle. This is a circle. Clear? Now, point was given. A point is given here. Here is a B point. Here is C point. Here is D point. So A and C are diametrically opposite. B and D are diametrically opposite. Clear? Okay. Now, what is the radius given? The radius given here. This is the center of the circle. O. And the radius here to here. The radius R is given as 4 meters. 4 meters is the radius. Okay. Now, observe carefully. In the first one, he is asking what? First one, distance. Distance is asking. He is interested in the distance. So, initially from A to B, path length. A to B, path length. Then B to C, path length. Then C to D. A to B, B to C, C to D. Okay. Now, observe. Total circumference is how much? Total is A, B, C, D. Complete total is how much? 2 pi r. Now, how much is here? It is traveled only 3 quarters. First quarter A to B, second quarter B to C, third quarter C to D. Fourth quarter is not complete. That means out of complete 2 pi r circumference, only 3/4 of the quarters completed. So distance is equal to 3/4, total 3/4 of 2 pi r. 2 pi r is the circumference. 2 pi r is circumference. 2 pi r, capital R here. 2 pi r is circumference. Out of complete circumference, complete total circumference, 2 pi r, only A to B, B to C, C to D, path length. 3/4 of the path length is traveled. Clear? Now 3/4 into 2 pi into radius is how much? 4. So 4 cancels. How much? 6 pi meters. 6 pi meters. The complete distance traveled. 6 pi. M stands for 3/4 of the 2 pi r. 4 cancels. Only 3 quarters. 3/4 of the quarters. Okay. Observe. This is, here I am showing the data line. This is 1 quarter. This is another quarter. This is third quarter. So giving the simple numbers here. First quarter, second quarter, third quarter, 3 quarters. Fourth quarter is not complete. Clear with the distance. Now, what is the displacement? What is displacement we require? Displacement is what? It is the shortest distance between the initial point and final point. So initial is A, final is B. So length of the straight line joining the initial and final. So this here I am highlighting. A is initial point, D is final point. D is final position. Now observe carefully. This is a right angle triangle. AOD, right angle is here. AOD is a right angle triangle. AOD is a right angle. And this AO is radius and OD is also radius. Here I am highlighting. Observe. So AOD. So AOD is a right angle triangle. AOD, right angle triangle. This AO is radius R. OD is also radius R. Okay. Now AD, displacement. AD is a displacement. AD is displacement. Okay. AD is displacement. So in the right angle triangle, simple Pythagoras theorem we are using. Okay. So here I am highlighting. This is the right angle triangle. So AOD. This is R. This is R. This we require AD. So AD square is right angle is here. AO square plus OD square. So R square plus R square. So finally, AD is under root of R square plus R square 2R square under root. So it is root 2 into R is out of the root. R square root is R. Root 2R. So displacement here I am highlighting. Displacement AD is equal to root 2 R. R is how much? R is radius is how much? Radius is 4 meters. So 4 root 2 meters. This is the answer. Okay. Hope you have understood carefully. Direction is always from the A to B, initial point to final. Okay. A to B, and you can calculate it in terms of theta also. If you observe displacement vector AD, theta with respect to AO, then tan theta in this case, tan theta is opposite side R by adjacent side R by R is 1. So tan theta is 1. So theta is 45 degrees. Theta is 45 degrees with respect to AO. Clear? Okay. So the problems are very simple. And whenever you solve the problems, project your entire concentration on the concept first. Then you attempt. Okay? Like the channel, please subscribe the channel. Like it, share it, encourage the channel. Thank you very much for your patience.